Hello friends, welcome to today's lecture Stress and Strain. Myself Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatra. In this lecture, we discuss about problem on volumetric strain and relation between three elastic modulus. So in last lecture, we discussed about how to calculate volumetric strain. In this lecture, we see one problem on that. So this is a problem, a rectangular block of size in x is equal to 600 mm, y is equal to 800 mm and z is equal to 1000 mm, subjected to a triaxial stress system. The stresses in the three mutually perpendicular are sigma x is equal to 100 Newton per mm square tensile, sigma y is equal to 100 Newton mm square tensile and sigma z is equal to 100 Newton per mm square compression. Find the net strain in each direction and hence the change in volume of the block. Take E is equal to 200 giganewton per mm square and m is equal to 3, that is Poisson's ratio. 1 by m is a Poisson's ratio. So this is the sketch. X is equal to 600 mm, y is equal to 800 mm and z is equal to 1000 mm. So this is the x, y and z. So let us see solution of this problem. So we know that strain in x direction, when load applied on the x, when you calculate the Ex, so linear strain in x direction and lateral will be y and z. Similarly, when load applied on y, the linear strain is on the y direction and lateral will be x and z. When load applied on the z axis, the linear will be z and lateral will be x and y. So strain in x direction is strain Ex is equal to sigma x by E minus mu sigma y by E minus mu sigma z by E. So sigma x is 100 and sigma x and sigma y are tensile force and sigma z is a compression force. So sigma x plus 100 divided by 200 into 10 raised to 3 minus mu is 1 by 3, that is 0.33 into 100 divided by 200 into 10 raised to 3 minus 0.33. Now this minus sign consider because the sigma z value is a compression force, so or compression stress. So minus 100 divided by 2 into 10 raised to minus 3. So calculating this all values, the Ex value will be 5 into 10 raised to minus 4. Positive sign indicates the nature of the strain is tensile. Then strain in y direction. So when you calculate Ey, so sigma y by E, this is a linear strain and x and z is a lateral strain. So mu sigma x by E minus mu sigma z by E. So sigma y 100 divided by 200 into 10 raised to 3 minus 0.33 into 100 divided by 200 into 10 raised to 3 minus 0.33 into minus 100 divided by 200 into 10 raised to 3. Minus sign indicate compression nature. So simplifying this equation, we got 5 into 10 raised to minus 4. Then next, strain in z direction. So Ez is equal to sigma z by E. This is a linear strain and this y and x is a lateral strain. So minus mu sigma y by E minus mu sigma x by E. So sigma z is a minus 100 divided by 200 into 10 raised to 3 minus 0.33 100 divided by 200 into 10 raised to 3 minus 0.33 100 divided by 200 into 10 raised to 3. By calculating all calculations, Ez value is minus 8.3 into 10 raised to minus 4. Now change in volume, that is delta V. How to calculate delta V? We know that the volumetric strain is equal to change in volume upon original volume. So EV is equal to Ex plus Ey plus Ez. We know the value of the Ex, Ey and Ez. Ex is equal to 5 into 10 raised to minus 4. Ey is equal to 5 into 10 raised to minus 4 and Ez is equal to minus 8.3 into 10 raised to minus 4. So delta V by V is 1.7 into 10 raised to minus 4. So change in volume is equal to EV into volume, that is 1.7 into 10 raised to minus 4 into V. So how volume is equal to LBH, 600 into 800 into 1000 into 1.7 into 10 raised to minus 4. So delta V is equal to 81.6 into 10 raised to 3 mm cube. This is the change in volume and this is the final solution. Ex is equal to 5 into 10 raised to minus 4, that is strain in x direction. Strain in y direction is 5 into 10 raised to minus 4 and change in volume is 81.6 into 10 raised to 3 mm cube. This is the solution for calculation of volumetric strain or change in volume. Next, we discuss about elastic constant. Already we know the elastic constant. Three elastic constants, that is Young's modulus E or modulus of elasticity, modulus of rigidity and bulk modulus. So let us see one by one. First, modulus of elasticity. Within elastic limit, the ratio of longitudinal stress to longitudinal strain is called as modulus of elasticity. Means that is stress by strain and it is denoted by capital E. Then next, modulus of rigidity or shear modulus. It is same as per that modulus of elasticity but is related with the shear stress and shear strain. Means definition of the modulus of rigidity is within elastic limit the ratio of within elastic limit the ratio of shear stress to shear strain is known as modulus of rigidity. Means similar that for modulus of elasticity, but now consider shear stress to the shear strain and it is denoted by capital G. Then next one, bulk modulus. Bulk modulus means when a body is subjected to three mutually perpendicular stresses, then its volume changes. Within elastic limit, the ratio of direct stress to volumetric strain is called as bulk modulus. Means suppose on a body three mutually perpendicular forces and equal in nature applied on that particular body, and due to that applied forces the change in volume occurs and that change in volume occurs. So within elastic limit, that direct stress to the volumetric strain means direct stress, that is sigma, divided by volumetric strain is EV. So and it is denoted by K. So bulk modulus is equal to direct stress divided by volumetric strain, that is sigma divided by EV, that is volumetric strain. Now we discuss about relation between modulus of rigidity, bulk modulus and modulus of elasticity. So E, G and K. So this is the relation between first E and K relation, that is E is equal to 3K in bracket 1 minus 2 mu, where mu is equal to Poisson's ratio. Then E and G relation, E is equal to 2G in bracket 1 plus mu. And relation between three modulus, that is E is equal to 9GK divided by G plus 3K. This is the most important relation. So let us see one problem on find out the three elastic modulus. A bar of 20 mm in diameter is tested in a tension. It is observed that when a load of 37.7 kN is applied, the extension measured over a gauge length of 200 mm is 0.12 mm and the contraction in diameter is 0.0036 mm. Find the Poisson's ratio and elastic constant E, G and K. So let us first write given data. So diameter of the bar is 20 mm. So corresponding area is 314.15 mm square. So length of the bar is or that gauge length is 200 mm. Then change in length is 0.12 mm. Then change in diameter is 0.0036 mm and the applied load is 37.7 kilonewton. So first we calculate linear strain. Linear strain means along that parallel to the load. So change in length, linear strain is equal to change in length upon original length. So change in length is delta L is equal to 0.12 mm divided by original length is 200 mm. So linear strain will be 0.0006. Then lateral strain. Lateral strain means change in diameter to the original diameter. So change in diameter is 0.0036 and original diameter is 20 mm. So lateral strain will be 0.00018. Then we know the Poisson's ratio. Poisson's ratio is equal to lateral strain divided by linear strain. So lateral strain value is 0.0018 divided by linear strain is 0.0006. Here is one mistake, that is this lateral strain is 0.00018. The Poisson's ratio is mu is equal to 0.3. Then we know the change in length formula, delta L, already discussed in lecture number 2. Delta L is equal to PL upon AE. So change in length, we know the change in length, that is 0.12 mm. We know the value of the P, that is 37.7 kilonewton, converted into Newton, that is 37700, into length is 200 mm and area is 314.15 into E. So in this equation unknown term is only E. By simplifying this equation we got E is equal to 200 into 10 raised to 3 Newton per mm square. Then using relation E is equal to 2G in bracket 1 plus mu. So 200 into 10 raised to 3 is equal to 2G in bracket 1 plus 0.3. So simplifying this equation unknown term is only G. So G is equal to 76.924 into 10 raised to 3 Newton per mm square. Then E is equal to 3K in bracket 1 minus 2 mu. So E is equal to 200 into 10 raised to 3 is equal to 3K in bracket 1 minus 2 into 0.3. So in this equation unknown term is K. So K value is equal to 166.67 into 10 raised to 3 Newton per mm square. This is the solution to find out elastic modulus. For calculate the elastic modulus, we know the change in length, change in diameter. By using that change in length and change in diameter, we can calculate Poisson's ratio. And by using that change in length, we can calculate Young's modulus E. And if you know the Young's modulus E and Poisson's ratio, remaining two modulus we can find out easily by using that relation between three elastic modulus. Thank you.